Continuing with the Unit 5 exam review, page number 2, questions 10, 11, 12, 13, 14, 15, 16, 17, and 18. We are not going to do question number 11. I decided to throw that out, so scribble, 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 scribble. That one is gone. We'll focus in on question number 10. Now here I'm telling you that the two triangles are congruent. Triangle WXY is congruent to triangle ZYX. So we can go ahead and pull some information out of the triangle, the first being that WY is in fact congruent to ZX. I chose those because that actually has the variable P on it. Let's go ahead and set up the equation from that. So WY is made up of two segments, 7P plus 13 and 2P. And XZ or ZX is made up of two segments, 2 and 20. So I will take the expression 7P plus 13 plus 2P should be equal to 2 plus 20. Let's go ahead and solve this equation. Combine like terms on both sides. 9P plus 13 equals 22. Subtract 13 from both sides. Gives us 9P is equal to 9, or P is equal to 1. Next question. Next, several sets of questions actually say, find the value of the variables that would verify the two triangles are congruent. So here I'm telling you they are congruent, so we set up CP/CTC, congruent parts of congruent triangles are congruent. Here we're going in the reverse. We're going to set up a congruent part of a congruent triangle we hope will actually be congruent. There's actually, we should get an equivalent statement and find the value of X. So, in question number 2, given information that those triangles are congruent, specifically, angle 4. So angle 3 is in fact congruent to angle 4. X equals 7x minus 10. We're going to solve this now. Subtract 7x from both sides, giving us negative 6x equals negative 10. Divide by both sides by negative 6. X equals negative 10 over negative 6, which simplifies down to 5 over 3. Next problem. We're again trying to find X such so that ARC is congruent to triangle ARB. From the congruency statement that we'd like to see that AC is congruent to AB. AC congruent to AB. So we'll go ahead and set those expressions equal. Now I'm going to go ahead and solve these. We'll start by subtracting 4x from both sides. 8 equals 3x minus 4. Add 4 to both sides. 12 equals 3x. Divide both sides by 3. X is equal to 4. X equals 4. Next problem. We're going to hopefully show that triangle DAB is congruent to triangle DC. From the congruency theorem, we can see that AB is congruent to CB, AB is congruent to CB. So we're going to go ahead and set those expressions equal. So x plus 3x is equal to 9x minus 8. Combining like terms on the left-hand side, 4x equals 9x minus 8. Subtract 9x from both sides, negative 5x equals negative 8. Divide both sides by negative 5, negative 8 over negative 5, which equals 8/5. X equals 8/5. Next problem. Question number 15, we want to prove that we want to show the triangle WRS is congruent to ZST. There's actually an error in this. This should actually say WSR. WSR congruent to WSR ZST. Let's take a look at what congruency statement we can pull out of that. WS congruent to ZS. Let's go ahead and set those equal. X squared plus 2x equal to x squared plus 24. We'll subtract x squared from both sides, so those zero out. So 2x equals 24. Divide both sides by 2. X is equal to 12. Okay. Notice again, in those 5 problems, we're using the triangle congruency theorem to find angles or sides that are congruent, then setting their expressions equal and solving for the missing variable, plugging that variable back in if I need to. For instance, on this last problem, if I asked you to find the length of SZ, you could. If I asked you to find what SZ was, we know that x is equal to 12. We can plug 12 into this expression and simplify it down. 12 squared being 24 plus 24. I'm sorry, 12 squared is 144 plus 24 would give us 168. We can resubstitute if we need to, but again, using the triangle congruency theorems to set up equal angles or equal sides, plugging in the expressions and solving. Next question, question number 16. State what additional information is needed. In the figure, we know some congruent angles and sides. So I know that angle C is congruent to angle Z. I know that AC is congruent to. Well, I want to go ahead and I wanted to figure out one other piece of information that shows the triangle ABC is congruent to WYZ. Okay, let's take a look at this. Going through the pieces of information, BC congruent to YZ. BC congruent to YZ would give me a side, angle, side. That's actually what I want. Side, angle, side, triangle congruence. Taking a look at the other pieces, AB and XY. AB and XY, that would give us side, side angle, which does not work. BC congruent to XZ. BC is one of the pieces we wanted, but we don't want to be congruent to those pieces already there, so that doesn't make any sense. And then XZ congruent to XY. Those are on the same triangle, so that doesn't even make any sense why I would set those pieces equal. So all of those fail. Answer choice A for us there. Number 17, what information is needed in order to prove hypotenuse leg? Take a look at this. For hypotenuse leg, I need a right triangle, which I have in both. I need a hypotenuse, and I need a leg. Well, we can see that the leg of this triangle, PS, is in fact congruent to PS via the reflexive property. So really, the other piece of information that I need to add into the triangle is I need a hypotenuse, congruent to hypotenuse. So here I'm looking for PR congruent to PQ in order to get the full right triangle and a hypotenuse leg triangle congruency theorem. That'll be my answer there. Next question, what information is missing for side angle side? Let's take a look. For side angle side, I need a side, which we technically have listed here. And we actually also have this side in the middle, congruent to itself. So we have that DB is congruent to DB by the reflexive property. So really the only thing I'm missing is an included angle. If I'm looking for an included angle in this top triangle, I need this angle here to be included, and this one I need this angle here. So the included angle that I'm missing is angle CDB, my top triangle, to be congruent to angle ABD in order to prove side angle side triangle congruency theorem. Additional information is important. Figuring out what is the one additional piece we're missing. In each of these cases, you can kind of see that we had two pieces of information, but one was almost implied in the diagram. So again, that was the reflexive portion. It was implied in the diagram. It's good that we listed it. However, we really are looking for what is the thing you need to physically add into the diagram and make that extra leap in order to actually get it. Thanks.